Welcome to this M2 video on constant acceleration formulae. So we can use calculus to derive the formulae for motion with constant acceleration, and in certain situations in exam questions it might say, without making the use of the kinematics formulae, show that or solve this or find this. So there are going to be times where you have to use calculus to solve a problem that you would normally use the kinematics formulae for, the SUVAT formulae. Okay, and that's what we're going to look at today. So I think the first thing to do is to look at the first example. And here it is. So a particle moves in a straight line with constant acceleration a, given that its initial velocity is u, and its initial displacement is 0. Show that its velocity v at time t is given by this, and then the displacement show that. Okay, so we're going to start off with the initial velocity, or the velocity. Okay, so velocity is the integral of acceleration, and this is part A. So let's integrate this. So a is going to be treated like a constant, like if it was a number 4 or a number 5 or 10 or whatever it is. Okay, a is just a constant. We're integrating with respect to t. So this is going to become at plus c. Okay, now we know that when t equals 0, the initial velocity v, or the velocity, sorry, is u. That means that u equals a times 0 plus c. Therefore c equals u. Hence v equals at plus u, and rearranging it as we want it like this, v equals u plus at. Okay, so there we have that initial formula, and we've done it with calculus by integrating. Now let's look at the second part, part B, find its displacement. So its displacement is when we integrate velocity. And velocity is u plus at. So that is what we are integrating. So this is going to become ut plus at squared over 2 plus c. And we know that when t equals 0, s equals 0. So we can substitute this in. So 0 equals u times 0 plus a times 0 squared over 2 plus c. So therefore c is equal to 0. So hence s equals ut plus a half at squared. And there we have the second formula via calculus. Nice, straightforward. Okay, now I'm not going to do any more examples on this. It is quite straightforward, but I will put up 2 past paper questions for you to have a go at, and I'll go through them at the end of the video as normal. And here they are. Now there is a part C for question 2, so pause the video now to have a go at question 1 and the beginning of question 2. And now let's look at the final part of question 2, part C. Pause the video now to have a go at part C. Okay, hopefully you're all done. Let's look at the answers. So I've got a particle moves in a straight line with constant acceleration. The initial velocity of the particle is 5 meters per second. So u equals 5. And after t equals 2, its velocity is 13. And we want to find A. So using our Suvat equations, we pick V equals U plus AT. V is 13, U is 5, T is 2, and A we want to find. So taking away 5, we get 8 equals 2A, A equals 4 meters per second squared. Okay, nice and straightforward there. Now let's look at part B. Without making use of the kinematics formulae, show that the displacement S of the particle from its starting position is given by this formula, or equation I should say, where P, Q and R are constants to be found. Okay, so if I want to not use the kinematics formula, it means that I am going to have to alright, I can't jump straight into S. I'm going to have to find V first of all, because S is the integral of V dt, but we don't have V, so V is the integral of A dt. Okay, now it's moving with constant acceleration of 4. So this is 4t plus c. So V equals 4t plus c. Now, from the question, when t equals 0, V equals 5. It's up here, the initial velocity, isn't it? Okay, so 5 equals 0 plus c, c equals 5. So we have V equals 4t plus 5. So now I have V. So now I can go ahead with my S, and I'm going to integrate 4t plus 5. So that's 4t squared over 2 plus 5t plus c, and that 2 will cancel with that 4. So S equals 2t squared plus 5t plus c. Now I have to work out what c is. And actually, because we've already used c in in the beginning of part B, let's make this another constant instead. So I'll use k. So when t equals 0, s equals 0. So you got 0 plus 0 plus 0 plus k. So k is therefore going to be 0. So s equals 2t squared plus 5. Okay, so in that case, let's have a look. P is going to be 2, Q is going to be 5, so that's 5t, and R is going to be 0. Okay, so that is question 1 done. Hopefully you're finding this video useful thus far. If you are, just hit that like button. Subscribe if you're yet to. And if you're willing and able to help me out financially, hit that join button. Otherwise, let's dig into question 2. So here it is. We have a train travels along a straight track passing point A at a time t equals 0 and passing point B 40 seconds later. Its distance from A at a time t is given by this. Find the distance AB. Well, it passes point A at t equals 0 and point B then at t equals 40. So when t equals 40, S equals 25 times 40 minus 0.2 times 40 squared, which is 1,000, and 40 squared times 0.2 is 320, which leaves us 680 meters. So that is part A complete. Now part B, show that the train travels with constant acceleration. So just like in the last one we were integrating, in this one we're going to be differentiating. Okay, so if I want to find V, it's going to be ds by dt. And that's going to be 25 minus 0.4 t. And that gives me my velocity. Now we need to show the acceleration. So acceleration is differentiating the velocity. So it's going to be 0 minus 0.4. Now the t disappears. Okay, the t disappearing means that this acceleration is just a constant value. Therefore it has constant acceleration. So the train has constant acceleration of minus 0.4 meters per second squared. Now part C, we've got a bird passing point B at time t equals 0 at an initial velocity towards A of 7 meters per second. It flies in a straight line towards point A with constant acceleration of 0.6 meters per second. Find the distance from A at which the bird is directly above the train. So let us just plot out or sketch what's happening. So now at t equals 0, we've got the train moving this direction. Okay, and this acceleration is minus 0.4. This time we've got the bird. I'm going to do a little dot with a couple of wings. It's travelling at 7 and its acceleration is 0.6. I'll leave it quite small for now, but you can get the gist of it. Now if I take this direction as positive, so the way the train is moving, because this minus 0.4 is obviously the deceleration of the train, then this is going to be minus 7 and this will be minus 0.6 because it's accelerating with 0.6 towards A, and this velocity is towards A, so the velocities are this direction. And then we want to find where these two meet. So we want to get something in terms of the displacement of the bird. So if we work our way backwards, so from the acceleration, and the acceleration is minus 0.6. So this is going to be minus 0.6 t plus c. But have we used a c? No, we haven't done any integration so far. Okay, now when t equals 0, its velocity is 7. So the velocity is minus 7 because of the direction. So minus 7 equals minus 0.6 times 0 plus c. So c is equal to minus 7 meters per second. Okay, just going to block that A and B off there. So therefore the velocity is minus 0.6 t minus 7. Okay, now let's get one for the distance. So this is all the distance of the bird. So we've got minus 0.6 t minus 7 dt. So 0.6 t squared over 2 minus 7t plus, let's call it d this time. So minus 0.3 t squared minus 7t plus d. Now when t equals 0, s equals, now this is not going to be 0 because it's at b, and all of this is from a, so s here is going to be 680. Basically our answer here to part A. So we've got 680 equals minus 0.3 times 0 squared minus 7 times 0 plus d. So d equals 680. Therefore s is minus 0.3 t squared minus 7t plus 680. Okay, so now I've got an equation for the distance of the bird. Now when the bird and the train are directly above each other, the distances are going to be equal. Okay, so when bird and train, oh, I suppose not bird and train, when bird is directly above train, their displacement, AS, is the same. So that means the S which we got from here, wasn't it, 25t minus 0.2 t squared. So 25t minus 0.2 t squared is equal to this. So getting it all on one side, we get 0.1 t squared. Now we're adding the 7t, so it's going to become 32t, and then we're taking away the 680. Okay, so times in by 10, t squared plus 320t minus 6,800. Obviously you don't need to, you could just about use your calculator and kind of work your way backwards from here. So we got t minus 20 and t plus 340 equals. So I use my calculator at this point. Okay, so when you go into your calculator, you can go into the equations and the polynomials and type this equation in. And you get 20 and minus 340, so you can work your way backwards to find out your values of that go into these brackets. Okay, now since t is positive, now let me just make a bit of room. Now, since t is greater than or equal to 0, t equals 20. So we know our time, then we can substitute it into any of our formulae. So, for example, I can now put it into the one for the train. Like so. And I get 420 meters from A. Okay, I could also put it into this formula, which I'll do just in red just to show you. S equals minus 0.3 times 20 squared minus 7 times 20 plus 680. So we get 0.3 times 20 squared is minus 120. 7 times 20 is 140, so minus 140 plus 680, and this equals 420 meters. Okay, so either way would have given me the answer there. And there you have it, question 2 complete, using calculus rather than formulae. Okay, so if you've found this video useful, don't forget to hit that like button, helps push this video out to more people. Subscribe if you're yet to subscribe, comment whatever you may comment. I do prioritize members' replies because I do get quite a lot of comments, and I'm just one person and I'm working as well. This isn't my full-time job. Okay, but speaking of that, if you're willing and able to help me out financially, hit that join button, and then hopefully in some point in the future I'll be able to commit more to these videos. Otherwise, I'll catch you in the next one.